Thanks very much, Joe. Thanks, everybody. I'm pleased to present some joint work that I'm doing with Sandy Gordon, who is also here, and then Zhihao Su, who's a grad student with us at NYU. It's a tool that we've developed called Data-NoMAD. It's a data integrity tool that we're hoping will help in addressing issues of fraud and therefore help to boost confidence in the integrity of social science data. Application at present is with regard to survey data collected on platforms like Qualtrics or Survey CTO. So Data-NoMAD, that's the name of our tool. What does it stand for? Data. And then the NoMAD part stands for Non-Manipulation Authentication Digest. And what this is a web app that uses hashing, essentially to generate a digital fingerprint of a data set, okay? The idea here is that you're collecting data on a platform like CTO or Qualtrics, right? And we consider the data that's collected there to be sort of the original source data that hasn't been tampered, right? And the idea here is to use hashing to create a digital fingerprint of that untampered data that can then be used as an authentication reference further down the line, okay? The tool operates in two modes. The first mode is what we call digest mode, and that's for the original researcher who's organizing the data to be collected on the platform. And then the second mode is what we call verify mode, which is for third parties who'd want to then authenticate a data set that would be posted to a replication archive or repository down the line. Currently, the tool works with Qualtrics and Survey CTO, and the hope here is that this tool, plus some best practices that we think complement the existence of this tool, could help to block avenues for fraud and allow researchers to show their integrity. So the way that this works is to basically create an opportunity during what we call the chain of custody, early part of the chain of custody of a data set, okay? So if you can think about the sort of sequence that a typical research workflow involves, you have data collection on a platform like Qualtrics or Survey CTO, and then what happens is that the researcher downloads the data locally, does whatever manipulations to the data that they need on their local copy, runs their analysis, and then ultimately posts something to a publicly available data set. And it's all this action that happens locally where fraud can take place, potentially. Now, we want to distinguish between legitimate versus fraudulent manipulations of data, right? We want to allow for the user, when they're working with their data set locally, to perform legitimate actions on the data set, such as redacting or removing certain columns to remove identifying information, allow for data transformations to take place that could then be included or used in the analysis, removing extraneous fields, deleting problematic responses, or allow for joins. We want to allow for all this stuff to happen, but what we want is something that can detect instances that would potentially be associated with fraud, such as editing responses in the data set, deleting rows, adding rows, deleting columns that might contain variables that, if they were included, somebody might want to look at and reassess the analysis, adding fake rows, adding fake columns, and so on. So we want to allow researchers the freedom to do what they usually do, right? But then to have a tool that allows us to evaluate, what was done to the data to detect potential cheating. So as I said, the tool operates in two modes. Digest mode, that's the mode that is available for the person who's creating the data and then working with it in the first instance. And what happens in digest mode is that, you have your data set. Let's say, you're using Qualtrics to create your data. This is the type of data table that Qualtrics would have for you, storing your observations, right? Then if you download the data using the tool that we've created, what will happen is that this original untampered data will be digested into a fingerprint like this, where what we're doing is to apply hashing to each of the columns so that you have a unique representation of each of these columns that could be used for authentication. This digital fingerprint, this hashed version of the data, then goes to our Data-NoMAD server. So it exists in this third-party repository that sits there as an authentication reference down the line. And you'll see by hashing, we're ensuring that, sensitive fields, such as the name of the respondent, for example, is not something that would be, interpretable or discernible, but it's there as part of the fingerprint, okay? Other data that could be sensitive as well are there as part of this fingerprint, as well as things that might not be sensitive, but they're hashed. Given that we're basically storing this in a third-party database, the analysis might be still ongoing. You'd want some embargoing of the actual underlying data. And so what this allows is for you to be secure in knowing that, yes, there is a fingerprint that could be used to authenticate your data, but it's not something that somebody could access and therefore like scoop you with your analysis or anything, scoop your analysis or anything like that. In verify mode, then, this fingerprint is there in our server. In verify mode, then, when data are at the end of, if you recall this chain of custody, ultimately posted to an archive, another person could then take the data from that archive and authenticate it, right? So what they can basically do is obtain the data from the replication archive, run it through Data-NoMAD, right? And what it would do is generate a fingerprint using the same hashing that was used to create the original fingerprint, and then just do a comparison to what's posted there on our server, right? Then what's going to happen is that Data-NoMAD will produce a report with the names of the columns and indicate to us any that were deleted, added, or altered. So we get this report back as to whether or not there was any manipulation of the data. Now, if you were to take data from a public repository, run it through Data-NoMAD, and have it and check it against this fingerprint that's stored in our server, different types of reports could then be generated. This would be an example of a report that might be problematic, right? So we have, some removed columns, right, such as IP address, name, and then this sort of metadata stuff. This stuff seems, reasonable potentially as removals that would reflect the desire to either just tidy up the data set or remove things that would be identifying information. Wouldn't seem to be a problem. However, it will also report back to you whether or not there are modified columns. And if you see a modification to a column, where there's no reason to think that such a modification like that would be in the interests of doing something like protecting privacy, that's a red flag, right? And so that's what our authentication tool allows you to view. What you would hope to see, ideally, would just be the removal of columns, that reflect an interest in trying to protect privacy. Okay, so this is a tool that currently exists to work with survey data on particular platforms. We have some ongoing and future work in process. There are some vulnerabilities, such as the ability to manipulate data from within these platforms that our workflow and the tool that we have can't currently address, and so we're trying to see how we can address those types of vulnerabilities. There are a bunch of best practices that we think you can use as a complement to this tool to create a very robust workflow. And then we're also trying to develop ways to adapt this to other types of data. So not just survey data, but other types of observational data that could be compiled from a variety of sources, or even administrative data. Thank you very much.